Good morning all, this is Manoram Krishna from Electrical for You. So today's topic is that synchronous motor. So I am going to discuss the today topic is that synchronous motor. So here the topic. So Electrical for You, we are from the Electrical for You, the formal known as For You Electrical. You can search on the Google or Facebook as their page is that For You Electrical. So here first we'll discuss the what are the topic we are going to learn in this topic. First, classifications of AC motors, comparison with the asynchronous motor, what is the AC motor, applications, advantages and disadvantages. Here for AC motor, so motor is a device which converts an electrical energy into the mechanical energy. So motor is a device which converts an electrical energy into mechanical energy. So if you give the AC supply, that is the AC motor. If you give the DC supply, that is the DC motor. In the both cases, the motor is a device which converts an electrical energy into the mechanical energy. These are the applications. Here, the AC motors are very popular used in the practice. So DC motors are not particularly used for the operations. So mostly whatever the applications are there, only we are using the AC motors only. Here, AC motors, the motors can be operated on AC supply. Here we have the classifications of the AC motors according to the principle of operation, according to the speed, according to the type of the current, according to structural features, according to the location. Here classification is based on the principle. The AC motors are classified based on the according to working principle, synchronous motor, asynchronous motor. The synchronous motor which will works on the synchronous principle, so it will run at the same speed the both operation. Here asynchronous motor is nothing but the three-phase motors, that is say comes to the induction motors of the asynchronous motor which will not run which does not run at the synchronous speed. The motors which will run at that synchronous speed, that is the synchronous motor. The motor which does not at synchronous speed, that's called the asynchronous motor. Here, so based on the according to the type of the current, here we have the AC motors and the based on supply, that is single phase motors and the three-phase motor. According to the speed, we are having the constant, adjustable speed and variable speed of the motor. And the type of the structural features, you having the closed type, open type and semi-closed type. According to the location, surface type or submersible. So suppose if you take the motor which will having the submersible pumps from the bore wells which will use for the submersible, and the surface motor which will use for the same case of the sump type. Okay, we have the types of the AC motors. Here, synchronous motor. So synchronous motor, the constant speed motor. It can be operated over a wide range of the power factor. It may be lead, lag, or unit power factor. It is a double excited machine which will give the AC supply as well as the DC supply. Here the AC supply is given to the stator terminals and DC supply is given for the rotor terminals. That will be going to discuss in the next. Here the induction motor, that is the asynchronous motor. This is the variable speed motor. It works with the lagging power factor only. The motor which will the lagging power factor is the induction motor. Here the advantage of synchronous motor. The power factor can be controlled easily enough by using the synchronous motor. Motor can work at lagging, leading and unity power factor. For the synchronous motor, if you run the motor along with the supply, it will give the supply power factor also changes according to that based upon how excitation you are giving for the motor. The speed is constant and independent load. Whatever the load is applying on the synchronous motor, whatever the load, the motor will run at the same speed. That's again synchronous speed. Here the sum of the disadvantages of the synchronous motor. It's not a self-starting motor. It's with the DC excitation. If it's DC excitation not possible for the always sometimes. So we having some methods to obtain the DC excitation for the synchronous motor. Here the initial cost is very high for the synchronous motor. It cannot be used for the variable speed drives due to it will having the only one speed, that is the synchronous speed. The motor is overloaded with the may follow the step. So if you overload the motor, it will be followed from the synchronization, it will have that. Okay, that's the main disadvantage of the synchronous motor. Here the tendency to hunting, that is coming for the hunt previous hunting bread. Here we have some applications of the synchronous motor that can be used for the power factor corrector. Even if the motor supply is having the lagging power, you can use this motor for power factor corrections. And the speed applications, constant speed applications like clocks, air compressors, and centrifugal pumps. Here, improving voltage regulation to long transmission line, which will having the lagging power factor. So improve that. We have to give the try to get the leading or lagging power improvement, so that we are going for using the synchronous motors and the transmission lines. The frequency changes, so some of the applications which we have is changing the frequency at the time we are using the synchronous motor. Here the details of this construction, we have the main points. So we'll go for the discussion of the construction features of the motor. We are having a stator and rotor. Here, how look at the synchronous motor having the stator with the long machine, which having slots and the stator frame. So here with the slots, we'll having the open type slots were placed. Here the winding will placing and by using this one. So the stator, which is a stationary member of the rotating machine. The stator frame and the DC excited. In the DC machine, the rotor frame serves to carry the magnetic flux. An alternative stator frame is a mean for the holding stator stamping and windings. In the stator core, the armature core is supported by the stator frame is built up of the laminations as well as special magnetic iron or steel. The core is laminated minimize the eddy current losses for the any of the applications. Okay, let us see how applications is going down. The laminations are stamping out the complete rings of the segments. Here the laminations are insulated from each other. The laminations have the spaces between them, allowing the cooling air to pass this one. The slots for housing for the armature conductors lies along the inner periphery of the core. So let's see how it is looking. So here the outer periphery of the synchronous motor and here I'm the rotor. Here we'll start the motor. So whenever the DC AC supply is given to the stator supply, we'll have the producing the rotating magnetic field according to the three-phase supply. That's rotating RMF production was induced in the air gap of the stator and rotor. So let's see how EM is still producing. Here the applications. So whenever the DC excitation is given through the DC brushes, here the rotor that will also induces the excitation, that is the DC excitation is giving to the DC supply, and magnetic field also induced in this one. Here, so how is that going down? So the north pole, south pole is also changes with the synchronization place plate. I'll start more like this. Okay, excitation split places. So let's see that. So here the rotor is the rotating member of the rotating machine. So having the silent pole rotor, we have seen that, and then silent pole are cylindrical type. The two types of synchronous motor, that is silent pole type and non-silent pole. Mostly we are using the silent pole type rotor. Here we see the silent pole rotor, the slip rings, how it is. We're having the schematic diagram of the winding. So here the turbine driven rotor, which having the slip rings according to that. Here the stator, we're having the three-phase supply. Here on the rotor, that is the silent pole rotor. So winding will have place player. Here the high speed 200 rpm or more the low speed application 200 rpm or less. So here how is the cross section will take places for the magnetic lines of force. Here we see that winding will having the armature field winding will placing the for the silent pole rotor, that is nothing but a projected type pole. Here we observe the silent pole rotor. It is a large number of projecting poles. We observe the large number of projecting poles. We can see observe this the large projecting toe. Here we are having the 4 poles machine. So it is at the largest number of the projecting poles. Their core bolts bolted and dovetailed on the heavy magnetic wheels of the cast iron or the steel. Such machines have the large dimensions or large diameters and short axle length. So we have already discussed now. If you know the operation of the alternator house having the projected pole type having the large diameter and the short axle length, so far for the low applications we're using alternator. Similarly here also for the synchronous speed, so synchronous motor also the silent pole rotor, that will also for low speed applications for the large diameter and the short axial length. Here the poles and pole shoes are laminated to minimize the heating and due to the eddy currents which are producing there due to the rotation of the magnetic field and EMF induced in the slots. Okay, here so it will be used for the low and the medium speed application between rotor having the silent pole rotor of the machine. Here the how 2 pole silent pole rotor which you can observe there. Here they are indicating that the 3-phase supplies is giving the different windings. So here showing the R, Y, B windings, and we are having the field windings placed in the rotor, that is the north pole and south pole, the projected poles showing the only 2-pole machine, and here cross means supplies here how current is flowing to the and coming from the outside. In going inside and outside current is a dot, and the cross marks indicates that the current flowing directions is the rotor. Here the silent pole rotating inside the air gap, how it is going to rotate there. In this way the rotor is rotating in this way. So here the smooth cylindrical type rotor, how it is will look like for the in a synchronous motor in the air gap, how it will be having the windings in the machine. So some of the features we have in the synchronous smooth cylindrical type rotor. So it is used for the steam turbine given the generators. Rotor consists of smooth, solid, forged steel cylindrical having the number of slots. Such rotors are designed to the 2-pole turbo generators, and these rotor poles are non-silent pole and do not project it out. So that's why having the short diameter and the long axial length. Those are why using for the turbo generators. So the rotor field windings excited the separate DC supply through the slip rings. Here rotor carries the special winding called the damper winding, and the damper windings consist of short circuited copper wires embedded in the pole faces. So the function of the damper windings are develop the starting torque and they prevent the hunting. So so whatever the damper windings there, how it is will look like, we'll see that in this video. So here we're having the machine which is having the only the field winding, that is having the projected pole type. So to start the motor for the self starting, so we have to put it in the damper winding, so it will be like that. So it will having the like this. This is a damper winding which will providing so magnetic core. So you observe that is the projected type. So let's see that short term like this. Okay, so giving to the initial rotation, so we're having that. So here damper windings will placed for the initial rotations. Okay, like it will start in the initial rotations, we are giving the damper winding. Okay, at the time to producing the high voltage during the supply, so it causes the damage of the voltmeter when you placing the in between the R and Y phases and Y and B phases while in the supply. So that's why in the V and inverted V curves you did not put any voltmeter for the supply system. So this is the how damper winding is placed in for the rotor. So we'll see the topic. So the damper winding consists of short-circuited copper bars and embedded in the pole faces. The function of the damper winding is to develop the starting torque and prevent the hunting process. Here, so methods of the starting are synchronous motor is not a self-starting motor, so avoid that. We're having the excitation, so or the attraction between the two poles. So when two unlike brought to each other, that exists for it is known that when two unlike poles brought each other, there exists a force of attraction between the two poles. The two magnetic poles and the magnetic lock is shown in the figure like this. North and south poles coming to each other. Due to the magnetic attraction only, the synchronous motor is going to work for the applications. So it's a motor which is used for when two unlike poles are brought to each other. So there exists a force between the two poles, the north pole and the south pole. The two magnets are set to the magnetic lock. So based on this, the synchronous motor will work. That's due to the magnetic locking. So due to the magnetic locking, the synchronous motor is working. Here, if the one of the magnet is rotating each of them, if one of the magnet is rotating, the other one is also starts rotating the same direction with the same speed as shown here. So this condition is referred to as a magnetic locking. So here we are having the stator magnetic field and the rotor magnetic field. So let us see how it is having the magnetic locking in the synchronous motor in a view of the video. So here we are having the rotor magnetic flux and stator magnetic for how it's place taken and the magnetic locking. Let's see. Here we are producing the magnetic locking, how it's placing. Let's see. Okay, so this is the copyright issue. I'm not showing the video, so I will put there this video description link, so you can go through this link and you see the actual video of the how synchronous motor is operating. So due to the copyright issue, I'm not putting the overall video. Sorry for that. So let's see how it's producing the magnetic locking. You can observe that here these are these for magnetic flux which will induce in the rotor, and these magnetic flux which will having the producing the rotating magnetic field, that is RMF production due to the stator. So whichever the AC supply is given, that will produced by the excitation of the AC supply, that rotating magnetic field induced in the stator and rotor area. So due to the magnetic locking between the stator and the rotor, so here synchronous speed is synchronization take place. This condition is called as a magnetic locking. So based on this, the synchronous motors are working in this way. So let's see. So you have observed the magnetic locking how did. So here the winding, the stator winding, the stator poles, they have laminated core, and here winding, that is a three-phase winding which will be producing a rotating magnetic field due to the excitation of the AC supply to the stator. And here we are giving the DC supply to the rotor, that is the DC supply, and you are observing the rotating magnetic field which is inducing by the excitation of the AC. So due to the magnetic locking with the rotor and the stator, so here the motor will work like this. Okay, so the out of synchronous take places due to the starting, that will be having the hunting process. To avoid that, at the initial position we place in the magnetic damper winding there's initial rotations here. So motor is overloaded at that time only, the motor will go for the upward synchronization. Okay, so to avoid that, motor is just not for the low speed applications, low load only. Here some disadvantages we are discussing now as well. So we have understanding. So how will like that? Okay, here the principal operations when the three-phase winding is fed by three-phase supply, and magnetic flux that's a constant magnitude but rotating at a synchronous speed is produced. Here So I can see the two pole machine as shown figure. The poles are marked the north pole and south pole, and the rotating at the synchronous speed the same the clockwise direction. Rotate poles at the instant situation the point A and B like this. So here the south pole and north pole, and this by excitations giving for the A supply and the DC source which is given for the rotor, that north pole and south pole, the which having the same synchronization. So here the two similar poles of the north of the rotor and north pole of the stator as well as south and south will be repel each other at the starting of the motor. So the rotor tends to rotate in the anti-clockwise direction. So hit the north pole and the south pole at the point A. So it's showing the north pole and south pole at the point A. So here, so but half of the stator poles having rotated around the interchange their position. Under this condition, the so after that, so here we are having that. So we have the for the positive and the negative, okay, at the half of this pole. Okay, after that the poles it will interchange this one A, this one. So half of the this situation is talking about. So under these conditions, north pole south poles attracts, and south pole and north pole attracts at the point B. So hence rotor tends to rotate in the clockwise direction, which is just reverse of the fast direction. Hence we find that due to the continuous and rapid rotation of the stator poles, rotor is subject to the torque, so which will rapidly reverse in the quick succession. So rotor is subject to the torque, which tends to move first in one direction, then in the opposite direction. Here the rotor cannot instantly respond to the quick reversing of torque due to the large inertia that results in the remain stationary. So due to the locking, so at the first station, so it does not rotate for the motor due to the interchanging of the poles, does not produce in the magnetic locking in between the stator and rotor poles. So due to that, the motor is not rotated due to the self-starting of the synchronous motor. In this way, the motor is not self-starting. So to avoid that, we are having the constant like this, it will be clockwise and clockwise. Methods of the starting. So here the sum of the methods which will be start the for the synchronous motor. So rotate the speeded up to synchronous speed by sub arrangement, then excite the DC source. Here we are give to run the motor first, and we have to give the then excitation. Sub moment near the synchronous rotating speed is excited. So first we have to rotate the motor as like an induction motor, then we have to apply the DC excitation, then the motor will works at the synchronous speed. So to add that, so we are giving the damper winding for the rotor. So the moment is near the synchronous rotating rotor is excited, it is a magnetic locking position stator. So rotor poles are engaged the stator poles, and both run synchronous in the same direction. The characteristics of the synchronous motor: the motor runs at the synchronous speed only. It's the enhanced self-starting. So that means it not a self-starting means it can be operated over wide range of the power factors, both in leading and lagging power factors. So these are the applications of the synchronous motor and the working principle and applications of the synchronous motor. Hope you understand hope you understand the topic. So some of the description link will go through that, so you will get the how working animations of the videos. I'll put in the description link, so go through that. Thank you. This is the Manam Krishna hosting from Electrical For You. So you can go to our Facebook page, that the For You Electrical, as well as our website, that the electricalforyou.com. Thank you.